This is page 205 in Incredibles book. This is examples 1 and 2. We are doing optimization problems. So the topic here is really not new calculus. This is just word problems with calculus and apply. All right. We're optimizing, meaning we're going to find the least amount of something or the most amount of something. So here in this problem, we're finding the dimension of the page that has the least, that uses the least amount of paper. Okay. So in these problems, you're going to be given two pieces of information, at least two pieces of information. One information is set up an equation. That's just an equation relating to things. And then another equation that you want to optimize, to want to maximize or minimize. Okay. All right. So let's look at the first sentence. A rectangular page is contained 30 square inches of print. Okay. So let's say we have a rectangular page, and inside it's got 30 square inches of print. 30 inches squared. All right, 30 square inches of print. The margin on each side are 1 inch. So when we say we have a 1 inch margin here, 1 inch there, 1 there, all around 1 inch. So inside, let's make these dimensions x and y. So x times y equals 30 square inches. So that is the area of the inside. Now, what is the area of the whole thing? The area of the whole thing is x plus 2 times x plus y. That's the area of the whole thing. Now, the width. So this equation, x times y equals 30, that is the equation that is relating x and y together. And then the second equation here is the one we want to minimize or maximize, or we want to optimize. We want the least amount of paper used. So x plus 2 times x plus y is the area of the actual paper. And since that's the area of the actual paper, that will be the amount of paper used. And we want to minimize this. Okay. And I wrote x plus y. I don't know why I wrote x plus y. It's y plus 2. Well, why is it x plus 2, y plus 2? Okay. So remember, this side, this way is x, and this way is y. So if I want to go all the way across, I've taken into consideration these 1 inch margins. So it's 1 plus x plus 1, making it x plus 2. And it's also going the other direction, y plus 1, making it y plus 2. So that's the area. X plus 2 times y plus 2 is the area of the actual paper. Now, this is in 3 variables. Area, x, and y. Let's reduce it to 2 variables. So I'm going to use this other equation to reduce it to, I'm going to use this other equation so I can rewrite one of them in terms of the other. So here, solve this for y, and I get 30 over x. So that means I can replace the y with 30 over x. So the area equals x plus 2 times 30 over x plus 2. So there we go. So now this is in 2 variables. Oh, essentially, I want 1 variable on this side. This is not a related rates problem. When I take the derivative, I want to take the derivative with respect to one of these variables that I have. Okay. So let's take a prime. Oops, actually, I'm not ready for a prime. What I want to do first is multiply this out because this is not very friendly. So x times 30 over x is 30. X times 2 is 2x. 2 times that is 60 over x. 2 times 2 is 4. Go ahead and clean that up some more. So 30 plus 4 is 34. Plus 2x plus, and I'm going to write that as 60x to the negative 1. Right? All right. So now I'm going to take the derivative. So a prime, 34 goes away. Derivative 2x is 2. That's going to be minus 60x to the negative 2. That means that, okay? That can be written as 2 minus 60 over x to the positive 2. Right? Remember, if it's a negative exponent, it goes to the denominator, becomes a positive exponent. We want to solve this for x. Why? Well, really, it's not that we want to solve it for x. We want to set it equal to 0, right? To get a critical number, set it equal to 0. So this becomes, what does this become? So bring the 2 over. So it'll be negative 60 over x squared equals negative 2 multiplied by x squared. So it's negative 60 equals negative 2x squared divided by negative 2. And I get x squared equals 30. X squared equals 30. So that means x equals square root of 30. Now, some of you might be saying, why isn't it plus or minus? Well, you're right. But I can't have a negative square root of 30 length of a paper, okay? Can't have negative root 30. All right, so we're going to have square root of 30. Now, what happens at this negative root 30 or square root of 30? Square root of 30, and then to the left of that, so that means I'm looking at this expression. If I plug in a number to the left of the square root of 30, say 1. Let's plug in 1. I don't want to plug in 0 because that's going to be undefined. So I'll plug in 1. 1 is to the left of square root of 30. Right? 1 is in this region here. So I'll plug in 1. That'll be 2 minus 60 is negative 58. So that means it's negative here. Plug in a number bigger than square root of 30. Square root of 30 is about 5 point something. So it's less than 6. Let's plug in, what do we want to plug in? How about square root of 60? Do you know why I thought of square root of 60? Because if I square it, right, it would be 60 over 60, it'd be minus 1. And square root of 60 is definitely bigger than square root of 30, right? So if I plug in square root of 60, I get 60 over 60, which is 1. 2 minus 1 is positive 1, so it's positive. Some of you might be wondering, well, maybe that's too big. Well, no, that's not too big. As long as it's to the right side of this number, it doesn't matter. That one number can represent everything in that region. All right? As long as that number was chosen correctly, and I have no doubt that it was. So that's it. So it's decreasing then increasing, though that is a minimum. Square root of 30 is a minimum. And that's what we wanted. We wanted the least amount of paper used. That's a minimum. Okay. So what are we doing now? So that was square root of 30. So x equals square root of 30. And remember here, we had this equation, y equals 30 over x. So y equals 30 over square root of 30. Basic algebra, that's equal to square root of 30. So the dimensions of the paper is square root of 30 plus 2 by square root of 30 plus 2. Remember, the square root of 30 is the dimensions of the inside. Square root of 30 plus 2 is dimensions of the outside. It's looking for the outside. So really, when I answer a word problem, I usually don't answer it this way. That's perfectly okay. On a test, for me, you can give me that. But if you're answering a word problem, you generally want to answer it in ways that the world wants you to say. So I'm going to put 7.477 inch. 7.477 inches by 7.477 inches. Right? And this is the reason I know it's a minimum. All right, so that's the answer to number 1. Let's look at number 2. All right, farmer plants to fence a rectangular pasture adjacent to a river. So here's a river. Here's a rectangular pasture. Pasture must contain 244,000 square meters. In order to provide enough grass for the herd, what dimensions will require the least amount of fencing if no fencing is needed along the river? All right, so let's call that x, call that y. So the area is xy, which is equal to 245,000. And the perimeter is the fencing needed. So perimeter equals x plus y plus x. Right? That's the perimeter. That's fence, that's fence, that's fence. So basically 2x plus y. All right. Now, so this relationship allows us to rewrite one variable in terms of the other. So let's make y equal to 245,000 over x. Okay. So we're going to replace the y with 245,000 over x. So perimeter equals 2x plus 245,000 over x. All right, now so this is what we want to minimize. So that's going to be p prime equals 2 minus 245,000 over x squared. Okay, I'm going to go ahead and just leave it like that. And if you need it worked out, this is very similar to the last problem, right? When we took a derivative of 60x to the negative 1. This is the same thing as 2x plus 245,000 x to the negative 1. So I'll let you figure that out. If you don't understand this, take a moment, stop the video, and work this out, and you'll get this. All right. So set this equal to 0 and solve. Because we're looking for the critical numbers for this, so I'm bringing the 2 over. All right, so that's negative 245,000 equals negative 2 over x squared. All right, so now we bring the x squared up, negative 245,000 equals negative 2x squared. Some of you might be saying, you can't do that because variable, what if x is 0? Well, it won't be 0. It can't be 0 because if it's 0, then that means you have no pasture, right? No pasture land. So it can't be 0. That's why you can multiply by x squared. All right. Divide by negative 2, and I get 1,22500. And it turns out when you take the square root of that, you get some nice number. At this moment, I don't remember what it is. And it looks like I can't really do that either. All right, so 350. I use a calculator for that. It's 350. Yes, it could be plus or minus, but if I have negative x, that means I'm going into the river, and I'm not going to fence up the river. All right. So x is 350. Let's see what happens. So I use 350 as my critical point, and I'm going to put 0 here, somewhere between 0 and 350. So if I plug in 1 into this expression, it'll be 2 minus 245,000. So that's definitely negative. Plug in something bigger than 350. What's a nice number? Let's say 700. All right, so 2 minus, I'm going to put that fraction up here, 245,000, 1, 2, 3, over 700 squared. 700 squared. Enter. Gives me positive, right? 3 halves, positive. So it's positive. So that's it. So it's a minimum. So I've shown that x equals 350 is a minimum by the first derivative test. So by first derivative test, x equals 350 results in a min. Results in a min. Therefore, the dimensions are 350 by, and then where do I get this? What is here? Y equals 245,000 divided by x. So y equals 245,000 divided by 350. And that gives me 700. So by 700. 350 meters by 700 meters. Yes, I'm sorry. I've had a long day. My handwriting is awful. Hopefully it makes some sense. If not, you are welcome to ask me questions in class. Have a good night. The secret word for today is Kierkegaard. Yes, that's not a real word. It's a name of a philosopher. If you tell me about this, I will give you 3 bit rewards or Hornet card rewards. Thank you. Bye-bye.